Hello everyone. So today we are going to start the last of our 4 units that we're going to cover here in distant learning or learning at home. Um, we're going to look at probability, so hopefully a relatively easy topic here to finish off with. Um, Reminder here that today we're going to talk about theoretical probability, and theoretical probability is just the likelihood that an event will occur. Remember that when we are calculating probability, typically we write this as a fraction, which we can convert to a decimal, and often we convert this to a percent. What's the percentage chance that something will happen? And if we think of this as a percent, we can go from 0% all the way up to 100%. And I've drawn a number line here. The idea just thinking that if we started at 0% and we go all the way up to 100%, in the middle, say, would be 50%. Okay, you might have something that is not that likely to happen, so maybe only a 10% chance. Maybe when it gets really hot, we have the chance of a thunderstorm occurring, so maybe there's an 80% chance of thunder showers today. Okay, at this end, if you get actually 0%, then we know with certainty that this event won't happen. If it says that there's a 100% chance of rain today, then we know that this with certainty will happen. So to calculate theoretical probability, what we will look at is what are the desired outcomes in some event that we are looking at, and then what is the total number of outcomes that are possible. So for example, in the first example here I have a set of playing cards, okay, a standard deck of 52 cards. Quick reminder that if you're not familiar, this symbol here is called the clubs. This symbol here is called spades. This is called hearts. And this is called diamonds. By color, both clubs and spades, these two will both be black. And both hearts and diamonds are red. Some specific cards. The first card is called the ace. Then we have cards 2 through 10. And then we have these cards here, which are called our face cards. Specifically, we have the jack, the queen, and the king. And together, those ones are called our face cards. So then we can ask questions like this here. So what's the probability if I'm going to draw one deck from the card? What's the probability that I will draw a heart? So basically we're looking at what are the desired outcomes. So if I count these up, okay, I would have 13 desired outcomes. 13 are hearts. In the deck, what's the total number of outcomes? There's 52 cards in the deck. So there is my probability, 13 out of 52. Now often students like to convert this then to a percentage. Okay, feel more comfortable understanding where do we fall sort of on this probability of happening if we write it as a percentage. So remember that a fraction just means to divide. So if we divide this on our calculators, we'll just keep 2 decimal places as we do this. So 0.25, and then I can convert this to a percentage. Okay, remember that we have to multiply this by 100 to change it to a percentage. You can either do that on your calculator, or really what's going to happen is this decimal place just shifts over 2 places, so we end up with 25%. What's the probability of a 2? So there's 1, 2, 3, 4 2's. So as a fraction, 4 out of 52 is our probability. As a decimal, if I divide those, we will get approximately, and this is where you do have to use your right rounding rules. I'll get 0.08, and if I then multiply by 100, we will get this to be 8%. What's the probability of a face card? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 face cards. So 12 out of 52. Divide them, gives us our decimal, which is about 0.23. Multiply it by 100, and we can write this as a percentage, 23%. So there's a common area that we look at when we're starting to learn about probability, is looking at playing cards. Another common area we look at is what happens if I roll a 6-sided die. Okay, so what's the probability I would get then a number that is 3 or greater? So 3, 4, 5, or 6. So I have 4 desired outcomes out of a total of 6 outcomes. If you divide this on your calculator, okay, you'll get 0.33 approximately. That decimal does go on forever. And if I convert this to a percentage, we get a 33% chance of getting a number that is, sorry, I'm looking at the wrong one here. So this should be 67, okay, 0.67, which is a 67% chance of happening. I was going to say that's too small, 33%. 4 out of 6 converts to 0.67 if we divide it, which gives us 67%. What's the chance that we would get a multiple of 3? Multiples of 3 are 3, 6, 9, 12, and so on and so on. Okay, think of what happens when you multiply 3 by other numbers. If we're talking about rolling a 6-sided die, only 2 of them are possible. So this means I would have a 2 out of 6 chance of getting a multiple of 3. If I divide that, this is our 0.33, or 33%. Lastly, what's the probability that we don't get a 2? Okay, so if there's only 1 2, then all the other options are possible. So there are 5 other options out of 6. Again, if we divide this on our calculator, you will get about 0.83, which works out to 83%. If we continue this idea with rolling die, in this case I'm going to roll 2 die, which we often do in a number of games that we play, where you roll 2 die and add up the dice. What's your total? So the first thing I want to look at is, what are the possible outcomes if we roll 2 die? In other words, this is your first die, so I'll say die 1, and this is your second die, die 2. So if the first die is 1 and the second die is a 1, okay, then the sum would be 2. If the first one is a 1, the second one is a 2, the sum would be 3. Here our sum would be 4. 1 and a 4, our sum would be 5. Hopefully you see the pattern here. There's our first row. What happens if I roll a 2 with a 1? So now I get 3. A 2 with a 2 gives us a 4. A 2 with a 3 gives us 5. And again, hopefully we can see that pattern. A 3 with a 1, 4. A 3 with a 2 gives us 5. And again, we get that same sort of pattern happening here as we fill in this table. 4 with a 1, 4 with a 2, and we get that same pattern again. 5 with a 1, 5 with a 2, and that same pattern. 6 with a 1, 6 with a 2, 6 with a 3, and so on to finish out our table. So there are all the possible sums that we could get if we roll 2 die. We can also see that some of the totals are more common. For instance, 7 is our most common outcome. There's 6 different ways that you could get 7. Our least common outcome would be to roll a 2. There's only one way to do that, or to roll a 12. There's only one way to do that. So in other words, if we look at this table, which is 6 by 6, 6 times 6 tells us this table has 36 possible outcomes. And yes, some of them are repeats, but there are 36 different combinations with those 2 dice. So then what's the probability that we would get a sum of 11? Well, there's 2 different ways that we can roll an 11. So we have 2 desired outcomes out of the 36 that are possible. And if we divide, we would find that this is about 0.06, or multiplying by 100, there's about a 6% chance that you would roll 11. What's the probability that we would roll a sum of 5 or less? So that would be then a 5, 4, 3, or a 2. So if I look on our table here, again, we don't just count this as 4 outcomes, we have to look at how many ways we can get these outcomes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possible ways to get these outcomes out of 36 that are possible. If I divide, I get 0.28, or a 28% chance that we will get a sum of 5 or less. Lastly, we can make up whatever scenario we want. Here I'm going to say at a school assembly, there's 100 students in grade 9, there's 125 students in grade 10, there's 225 students in grade 11, and 170 students in grade 12. Everyone at the assembly enters their name for a door prize. Find the probability that the prize will be won by a grade 9 or a grade 10 student. So if I look at 9s and 10s, okay, I need to add them up. There's 100 grade 9s, 125 grade 10s. So there are 225 desired outcomes. Okay, we're looking at desired as grade 9 and 10s will win over the total number of outcomes. So if we add up all of them, 100, 125, 225, and 170, I've gone ahead and done that ahead of time on my calculator, there are 620 students at the assembly. So there is our probability as a fraction. If I divide these, I will get approximately 0.36, or there is a 36% chance that a grade 9 or a grade 10 student will win. What's the probability that not a grade 9 student will win? We can look at this two ways. We can say that means either a grade 10, 11, or 12 student will win, and we can add those up. Or alternatively, if I know there are 620 students, and I don't want a grade 9 to win, I can just subtract that off my total, and very quickly I can see that there are 520 other students. If we divide that on our calculator, that will work out to about 0.84, which means there's an 84% chance that a non-grade 9 student will win. In other words, that a grade 10, 11, or 12 student will win. That's it for our introduction. There's an assignment posted, so give it a try, submit it when you're done. If you have any questions, let me know, and I can give you a hand. Have a good day, guys.